What I have here is a forward reversing motor starter. You have two starters, one for forward, one for reverse. There's an overload module connected to both. Circuit breaker limits the power going to the circuit. Start stop station, forward start, reverse start, stop, selector switch we're not using as of yet. To simulate the load right here, I have three lights, and I've cut the frequency down from 60 Hertz to 1/2 of 1 Hertz so we can identify and see the three-phase power rotations. Very simple, guys. Now, between the two starters is a little mechanical device called a mechanical interlock. That lock is present right there, so you cannot push down or start both starters at one time. You could only start one. So the interlocks do fail. So to back up the interlock is what's called an electrical interlock. This is where we have the closed and the open contacts. So we have an electrical interlock. It's going to be shown as on the drawing right here. So on this drawing we have the two coils, forward coil, reverse coil, and these little lines represent an interlock right there, mechanical interlock. So when the forward starter starts, the contact right here opens, disabling reverse. That would be the lower contact right here, the closed contact on the forward contactor. Power comes through the stop station to the start, passes through the closed reverse contact, energizes the forward starter, contact opens, holding contact closes. Same thing with reverse. Once we stop it, power goes straight down to reverse button. We push the reverse button, power goes straight through, energizing reverse, opens the interlock contact, closes the holding contact. The circuit's latched on. Well, the drawing looks like one thing, and that's pretty good, but the actual circuit itself looks a little bit different. Now we've got a big ball of wire. Now we have a big ball of wire. Now, the start-stop station's connected to the terminal strip. Sometimes you have terminals, sometimes you don't. If you have terminal strips, it makes it a heck of a lot easier for the troubleshooting process. But how this works is I go ahead and I push the forward starter. The starter energizes, power passes straight through the overloads, out to the load. You can see the rotation, in this case, is clockwise. Now, the overloads are only there to prevent all the wires and the loads from overheating and melting. When we're working with motor circuits and transformer circuits, when you start the circuit, there's a very high inrush current. So often the breaker overcurrent device upstream has to be much larger and will not protect the wires. So now the overloads are present as a backup to the breaker fuse. So if something goes wrong, it overheats, the overloads trip and shuts off the circuit. To trip the overloads manually, I'll simply trip them with a manual trip. It dumped the starter, killed the loads. I reset. Once I reset, it didn't start. I have to physically push the button again. We run forward. We have a clockwise rotation. We stop. We push reverse, and now we have a counterclockwise rotation. How that's achieved is we swap two wires. Now the power wires coming in here on the top land right here, three-phase wires, A, B, C. This little bar is a jumper wire, and that jumper wire jumpers A phase to A phase, B phase to B, and C to C. So we got the same power rotation coming in. Power goes straight through the starter contacts. But on the bottom of the starter there are jumper wires that actually swap the wire polarities. A phase is connected to C phase, B phase connects directly to B, and A phase here connects to C phase. So we're swapping A and C phases. If both starters were to start, you would have an arc flash, a face-to-face fault inside of one of the contactors, and that would turn the contactor into a fragmentation hand grenade. It blows up and explodes. So we don't want that to happen. So this is why the mechanical interlock is present, to prevent two from starting at the same time. But often right there, that doesn't actually work a lot. A lot of times these fail and they get defeated for whatever purpose. So we go back to the drawing right here, and you see how the interlock works. Forward starter starts. Okay, forward starter starts. Power goes through. All the red right here powers through the power circuit. We push the forward button down. The forward starter energizes. Contact opens. Holding contact closes. We let go of the button. Now the circuit is latched on. So this holding contact bypasses the switch. The circuit is latched. Now this contact will open if the overloads over here trip or open, or if somebody hits the stop button. So we push the button down, the stop button, it breaks the power to the circuit. Okay, we let go, the circuit's now reset. We push the reverse button. I skipped a slide. Power goes straight through to the reverse. Contact closes, contact opens, we let go of the button. Now the circuit's running reverse. Okay, we push the stop button and it goes back to normal. Power right here. Now looking on the drawing, this is very, very easy to work with. It's logical, it makes sense, but it does not look like this ball of wire down here. Not even close. Does not look like that ball of wire. So therefore, any time of working with any kind of circuitry, if you have the electrical drawings, the drawings show you where to take the measurements at. Right here, we have to understand what these are. These are contactors, 1, 2. On the side, we have auxiliary contacts, and each one of these have a normally open and normally closed contact, and those contacts operate when the contactor operates. The overload has got a little contact, 2 contacts, normally closed and normally open. Now, there is what's called a bimetallic strip inside of this overload, and that bimetallic strip bends and trips the contacts. But it only bends if the wires down here get too hot. So that monitors the heat of the circuit. This one opens the circuit. The closed contacts can be used right there to send a signal. Send a signal to, let's say, a PLC or a drive or an indicator light or a siren. If the overloads trip, you can send power through this part of the circuit for whatever purpose you need. Right here we've got a forward button, a reverse button, a stop button. I push stop, it stops, push forward, it goes forward. Currently the selector switch not in use in this video, but it will be used in the future. So forward reversing circuitry, guys. Not as complex as it seems.